Welcome to this video on the topic of binary numbers. In this video I'm going to show you the technique we can use to convert decimal numbers over to their binary equivalents. The way in which I'm going to do this is I'm going to show you 4 examples highlighting 4 different scenarios. Now starting with example 1, we have number 5 and we want to convert that to binary. To start off, what I'm going to do is I'm going to write out this pattern. I'm going to start off with 1, then I'm going to go to 2, 4, and then 8. So this pattern we saw in the last video where we converted binary to decimal. Now, reason I've stopped at 8 is because 8 is the first number in this sequence that is actually greater than 5. Now, because this 8 is greater than 5, what I'm going to do is I'm going to put a 0 underneath the 8. Then I'll just highlight it to show that I've ticked it off. Now, I'm going to move 1 to the left and highlight the 4. Then the question is 4 either less than or equal to 5? Now, in our case, 4 is in fact less than 5. So now I'm going to put a 1 underneath this 4. Then, I'm going to grab my 5, like so, and write it there. Underneath the 5, I'm going to write 4, like so. Now, I'm going to get a red pen, and I'm going to draw a bar underneath my 4. Then I'm going to put a dash to show that we're about to do division. Jumping into it, we're going to go 5 take 4, that's 1. And therefore, the number that we're now working with is 1. Alright, now, going back to our sequence, we get to the number 2. We ask ourselves, is 2 less than or equal to 1? And the answer is no, it is not. So we're going to put a 0 right here. Next step, we move to 1. We ask ourselves, is 1 either less than or equal to 1? And in this case, the answer is yes, it is. It is equal to it. So we're going to put a 1, then we're going to write 1, and we grab our red pen, we draw a bar, we go for the division, or the subtraction I should say, and then we subtract. 1 take 1 is 0. Now that we've got 0, we are done. Now, to actually write this out as a binary number, we need to reverse the order. So what we'll find is that 5 in decimal is the same as putting this in reverse, 0, 1, 0, 1, like so. Alright, now, next example. Let's grab example 2. Alright, now that it wants to move. Example 2, we're converting the number, or 154, to binary. Now the way in which we do this is we start off with our binary sequence. So we're going to go 1, 2, 4, 8, 16, 32, 64, 128, and 256. So remember, we count upwards until we get to the first number in the sequence that's either equal to or greater than our number over here. Alright, now let's do something slightly different, and we'll just throw down 154 to begin with, like so. Now we're going to go to 256, the last digit or last number in our sequence, and we ask ourselves, is 256 less than or equal to 154? And of course the answer to that is no, it's greater than it. So we're going to put a 0. Now, next number, 128. Is 128 less than or equal to 154? And the answer to that is it's less than, so I'm going to put a 1. Now I'm going to get 128 and write it down underneath 154. I then grab my red pen and we go for some subtraction. 8 take 4, we can't do that, so we go to the 5, we borrow 1 and we stick it in front of the 4 to make 14. 14 take 8, that is going to be 6. 4 take 2 is 2. 1 take 1 is 0. Now, the number that we're working with is 26. Moving on to our sequence, we go to 64 and we ask ourselves, is 64 less than or equal to 26? And the answer is no, it's not. It is greater than, so we're going to put a 0. 32, is that greater than or equal to 26? It is greater than, so we put a 0. Next one, 16, is 16 less than or equal to 26? And it's actually less than, so now we're going to put our 1, then we're going to grab our 26, or our 16, then we're going to go for some subtraction. Performing the subtraction, 6 take 6 is nothing. 2 take 1 is 1. Therefore, our new working number is 10, like so. Going back to our sequence, we look at 8. Is 8 less than or equal to 10? And the answer is it's less than. So we're going to put a 1. Now, we grab our 8 and we write it underneath, draw the bar and go for subtraction. 0 take 8, we can't do that, so we borrow from the 1 to make the 10. 10 take 8 is 2, and then we're left with 0 in the front here. 2 is now our new working number. We go to 4. Is 4 less than or is 4 less than or equal to 2? And the answer is it's greater than, so we're going to put a 0. Is 2 less than or equal to 2? The answer is it's the same. So we're going to put 2 and the 2 underneath, go for subtraction, and then get the resultant value of 0. Putting in the 1, which I should have done earlier, we go to 1. Is 1 less than or equal to 0? The answer is no, and therefore this is our new binary number. Now reversing it around, we get 1, 50, 50, 4, base 10. It's the same as writing, we read it from this way. So we're going to go 0, 1, 0, 0, 1, 1, 0, 1, 0, base 2. So remember, this number here is always going to be read backwards to this number that we wrote down over here. Reason for this is that if we use this method of counting upwards, when we look at this decimal number, we don't always know how many bits we're going to need, so we can't know to stop at 256. So what we do is we start from the left and count to the right, and therefore we always have some space. And the only offside is we just reverse the digit down here. So this is our number. Alright, let's go to example 3. We look at example 3 and we have the number 76. So of course we count up from 1, 2, 4, 8, 16, 32, 64, 128. Now we look at 128 and it's way bigger than 73. So we're just going to put down our 0. We look at 64 and we can see this is less than 73. So we're going to go 73, take 64, set that up as a minus, and we'll just quickly go back and put the 1 there. 3 take 4, can't do that. So we'll go 6, 13, 13 take 4 is 9, 6 take 6 is 0. So our new number we're working with is 9. Look at 32, we ask ourselves, is 32 less than or equal to 9? It is not. Is 16 less than or equal to 9? It is definitely not. Is 8 less than or equal to 9? In this case, it is less than. So we put a 1, then we put the 8 underneath, set ourselves up for subtraction, and then we get a result of 1. 1 is our new working number. Okay, we go to 4 here in the sequence. Is 4 less than or equal to 1? It is in fact bigger, so we're going to put a 0. We look at 2. 2 is bigger, so we'll put a 0. Then 1. We've got the 1 here. We're going to go 1 is equal to 1, so we're going to put a 1 there. And then just for completion's sake, we'll sort this out. Done. Alright, now next step is we need to reverse. We need to read from right to left. Therefore, 73 base 10 is the same as writing 0, 1, 0, 0, 1, 0, 0, 1, like so. So nothing to it. Okay, let's look at our final example here. Example 4. We have 256. Alright, now to convert this, we're going to go with our pattern. So we're going to go, and notice in this one I've stopped at 256. Reason for this is 256 is, it's not greater than 256 over here, but rather it's equal to, so we can actually hold it up there. Now, looking at this first number, 256 here, we're going to start off with our 256, then the number we've highlighted in yellow, that is 256. We set ourselves up for our subtraction, and then our resultant value is 0 all across the board. Thus our working number becomes 0, and therefore this one's actually a really fast one to do. We can just go 1, then put zeros in all the rest of them, because we know they're all going to be greater than our target number of 0 now. Okay, now following it through and reversing the numbers in green, we go 256 base 10 is equivalent to writing 1, 0, 0, 0, 0, 0, 0, 0, 0, like so. So quite an easy example.